Hi, welcome to Analytics for All. This is lesson 18 of my Python for Data Science course. In this lesson, we'll be covering generators. Now, as with all my lessons, I have a full write-up on my website, analyticsforall.org. I'll have a link down in the description for you for that. I hope you've had a chance to install the Anaconda distribution from my first lesson because I'll be using the Jupyter notebooks from Anaconda. If not, if you're on a phone, if you're on, a tablet or work computer and you can't install, if you look down on my site, if you look for any of the Python lessons, you'll be able to find these blue arrows throughout there, and they'll bring you to a Python testing shell I've installed that you can run on your browser. But let's go ahead, hop over here into the Jupyter notebook. This will be a quick one. Okay, so this is kind of a computer sciencey one here, because what the issue we have here is we're going to discuss lazily understanding data versus not. Okay, so what I've got here is a really quick iterator. I got instantiate I as 0, I put j as 1, and I got a loop here while j equals 1. And if I did one earlier, so I did a loop while true, this is the same thing. It will never stop until you tell it to break. I want you to print I and then increment I up by 1. If you didn't see this before, this I plus, this is the equivalency. This is the Python equivalent of I equals I plus 1. So it's stepping up each time. It's just shorthand. So plus equal sign 1. Or you can put 2, anything you want to increment by. But if we run this, this is going to freaking just run forever. This will never stop. And not only that, but the problem is, as it runs forever, all of these things get saved. So we just, in that couple seconds, I just finally broke it. But I mean, what did we get up to? We got up to 41,000. All right. It just created a list and saved them all. They're sitting there in memory. And eventually your computer's just going to run out of memory. And that's a problem, while you're trying to do, anytime. You don't want your computer to run out of memory. If you're writing programs that drive the computer out of memory, you're in trouble. So what we can do is we have a thing called generators. Now, a generator's lazily. What it means is it creates this iterator and it just forgets it. It doesn't save. It does not create a list of everything it did for it. It just counts it, prints it out, and gives it to you, and it's done. So a generator has to sit inside of a definition here, inside of a function. So I created one real quick. Function gen example for I in x range 1 to 10, x range 10, which I just make it short. Here's the command, yield. Yield has to sit inside a function. Yield cannot work outside of a function. So when I say yield, what I mean is I want you to spit this number out and then forget it. Just print it and forget it, or do whatever you're going to do with it and just forget it. Do not save it in memory. So for y in gen example, notice this function does not have a variable to send to it. Don't need to. And notice I don't have return. I have the word yield. Return would save it again in memory. So go ahead and we're just going to print y. So for y in gen example, and just print y, and there you go. That's it. And it doesn't look all that impressive when we're only dealing with a couple variables. But when you're dealing with sets like I deal with at work with billions of records, this is an issue. It becomes a memory issue. So that again, that's kind of generators and generators pop up in interview questions too. Just remember, generators are lazily. They produce data lazily, meaning they just spit it out and forget about it. They don't save it into a list. All right. Thank you very much. This is the lesson. Go ahead, please check out my website. If you like the lessons, go ahead, hit like, subscribe. Leave me a note below. Let me know what you want me to work on, and I look forward to seeing you again. Thank you very much. This is Analytics for All. Thank you.